And you mentioned in your response there how you're a product person. So I think this is interesting. So we mentioned right at the onset that you're the chief product officer at Pathway. But if I dare say, your background strikes me as the kind of background that somebody would usually have as a CTO, as a chief technical officer. So you have this very technical computer science background. I know you're still hands on today, writing code, and you're in this CPO role. So I think you might have given us a bit of a clue to the answer as to why it makes so much sense that you're the CPO. And it's because the Pathway product is designed for highly technical people. It's designed
Absolutely,
for software
absolutely. I think
developers.
the main goal of a product person is to understand the end user and to be like the end user. It makes things simpler, but at least to understand the needs of the end user and to be able to have a certain empathy for these needs. This is why I guess for a technical person it's easier to be a CPO of a developer product. I would say if it were not a developer product, I'd be completely disqualified. Just not kidding. I mean, it's like it's too tempting to switch sides and be part of a creative process and say, I mean, what if we could add to our data processing engine something else that and starts doing a tech push and so on. Yeah, I agree fully that this temptation exists, and it's it's kind of a bit of a complication always knowing how the internals work. However, being technical also means that I can actually test the product in action. I can write 5 lines of code in Pathway. I can see it. I can see if I'm able to showcase the things that we are promising ourselves. I can review some showcases or pieces of open source done by others using Pathway to see if it's all meeting the expectations that are made of it. Especially given that the state of data processing frameworks as it is such that the developer experience and the experience of maintaining them, scaling them, is one of the bigger issues, because things just either fall apart or don't work 100% of the time. So then the experience of actually introspecting, debugging is not optimal, and this is one of the bigger pains of data teams. And having time to experiment with how we can resolve these issues and work on the experience front is a major challenge and major, I think, opportunity also for the space to provide some improvements here.
Nice. That makes a lot of sense. And yeah, I can, it's crystal clear to me now when I was preparing for this episode. I was like, oh, this is kind of interesting. And then it started to become really obvious. Okay. He is the perfect product person because he is the ideal user of this product as well. So, speaking of your technical background, before Pathway, you were a computer science researcher for over 15 years, including at a renowned French institute called INRIA in French, and it translates into English as the French Institute for Research in Computer Science and Automation. And when you were that researcher for all those years, you published dozens of peer reviewed papers. You specialized in things like network science, distributed algorithms, dynamical systems, and the transport optimization that Pathway specialized in initially. So, do you have like a particular area from that time, from your research time, that was that you were really passionate about? Maybe you're still really passionate about today. It seems like complex systems, for example, were a recurring theme for you.
Definitely, definitely. If you zoom out, and look at a large system where things are moving, it can be in nature with ants cooperating in the task. It can be a transportation system. Then you look at how it's built, how it works, how the local interactions drive the system, and it's fascinating to observe this from also a computational perspective, and ask why it's working like this. So why is it working, and what does it achieve in this way, and can we learn from it? Can we learn things about it? can we learn certain approaches? Can we try to transfer them into computational paradigms? Or vice versa, can we use computational paradigms to explain complex systems? I think one of the recurring themes which exist in complex systems is this ability of distributed control and coordination, which is fascinating. Another which is probably closer to the, let's say, the big challenges of both machine learning and computer science for the next decade is one of low energy computing or energy optimization. If you look at distributed systems, they actually, through the fact that they are so distributed, they do things locally, they learn things, they improve things with relatively little interaction, little communication, little computation, and little cost. And for an ant, it's obvious that it cannot, use up more energy than it has, because it has to eat to get this energy. So it's kind of optimizing as well for the computation effort. It cannot have a bigger brain, because that would eat up its sugar. So there are things that trade-offs in nature that are driven by energy. In the let's say computing world, especially in the deep learning world, this is something that's kind of acknowledged, that we are not optimizing for energy, and that a lot of these computations are done in a way which just gets things done with by scaling resources up, scaling cost up. But since it's so important, we don't think about the energy impact. And actually the incremental way of computation, and also streaming computations, are more energy efficient. So it's somehow more natural for me to be in this space, which cares about the amount of data updates that are happening in these systems, and doesn't just recompute everything from the beginning.
Right. The ant brains in a streaming processing system don't need to be as big because they're just online making decisions one little piece of food at a time.
See,
One little next step.
fascinating. It's quite fascinating with ant brains. The more external storage an ant can rely on, like leaving pheromones, the less it needs to store in its head. If it cannot
Mhm.
rely on external storage, like because it's too hot in, let's say, the Israeli desert, then it has to do more computations, and they do rely more on internal storage, and the brain swells up. So these surprising trade-offs between like communication, storage, and computation happen in nature, and they're very like neatly captured by a lot of those
Wow.
models. So it's kind
That's
of,
so cool.
so yeah. I guess there are many challenges that nature and that complex systems are remarkably good at, that we haven't quite grasped. One of them is the ability to forget. This is one of the things that many natural systems have. They just naturally forget things they've learned, or they unlearn things. This is something that's not super easy with deep learning models. So uh, it is more the area where lightweight models, or models which have some kind of ability to add, delete data points, that they,
Mhm.
they that have an edge in this area, and it's somehow.
Mhm. Yeah, rich opportunity for more research there for sure. And so you made this leap from all these years of research into being a startup founder. How did you make that leap? And is there anything that you miss from being a researcher? It sounds like you still get to do a lot of fascinating research in the role that you're in.
Definitely, I get to miss the frustrating part of being a researcher. So, one thing that
Grant writing.
I've discovered is that it's actually gives more joy to deliver code, or like small showcases around code, which is open sourced, than to focus on the full effort of writing papers. Maybe GPT-4 will change that, and actually the paper writing part will be taken care of. We just have to focus on delivering the essence for now. But there are many exciting challenges in what we're doing now. That's true. I should say I'm not completely new to the enterprise slash startup world. Given that something like almost 20 years back, I started a programming community called spoj.com, spoj.com, which grew to be, in its day, one of the largest competitive programming communities. It was we really did it for the excitement of actually getting people to use to learn competitive programming to boost their skills, but we also needed a lifeline for it. And interestingly enough, the lifeline, the revenue channel there was through enterprise who were interested in putting into place a similar framework for their enterprise training programs in what was known as algorithms at the time, and then started being called data science, but with a gentle migration around 2010. But this was also an interesting experience for me, like drafting my first contacts and doing my first sales, and at the same time having this enormous opportunity, which was to drive a community, be part of a community, take feedback from a community, and to learn the things that I sort of need in to make the product better.